Hello friends, hope you're okay wherever you are. Let's try to look at this question which came in one of the past papers. I guess it's 2021 exam past paper, and it is under organic chemistry, introductory to organic chemistry, which is for pharmaceutical chemistry. Alright, so let's try to look at this one here. As I say, show how the following compounds could be prepared using appropriate alkyl halides. Your method should include analysis and synthetic route for each compound. No mechanism is required. So let's try to go through together. We're going to start with this the first question, so which is one. So here they're saying we need to use an appropriate alkyl halide for us to come up with this, which is an alcohol. When you look at that, you can see that this is an alcohol and it is a tertiary alcohol. So which alkyl halide can we use? Alkyl means so when they say alkyl halide here, it means here it can be an R, then here it can be a halide, either any in group 7. Those halogens are called halide. So it can be bromine, it can be iodine, it can be chlorine. Those are the halogens that we can add there. So now how can we use these and come up with this alcohol which we have here? So now we can also, as you can see, that this is a tertiary alcohol. We can use an SN1 reaction mechanism for us to come up with this. But at some point, you know, SN1 reaction and E1, they may compete at some point. So now we can have an alkene and also an alcohol at the same point when you use an alkyl halide, which is a tertiary, coming up with this using an SN1. So here the most good yield method that we are going to use is what is known as the reaction of a Grignard reagent. So now what alkyl halide are we going to use? Look here. So when we say this is a tertiary alcohol, when a Grignard reagent reacts with a ketone, it forms a tertiary alcohol. So like here, I'm going to see this. Now which alkyl halide am I going to use? Because I need to show it. And remember, I need to show the analysis part and also the synthetic part. So if I were you, in fact, I can start with synthetic route, because that's the best one when you start with that, so that in analysis part you just go a reverse direction. But I'm going to show how it goes. So here I'm going to get the, you know, the formula for or the formation of a Grignard reagent is alkyl halide, then reacting with magnesium, then it will form something as alkyl here, magnesium, then with the halogen there. That is a Grignard reagent. This is a Grignard reagent there. So now let me get the same thing and show it. So I'm going to say, what alkyl am I going to use? See this alkyl here, which is methyl, is the one that has been used here to be put there. So what am I going to do? I'm going to say CH3, which is mostly I use bromine. See, this is an alkyl halide there. I'm going to react it with magnesium to form CH3, CH3, then here magnesium, then here bromine, like that. You see, so the one that I've formed here is a Grignard reagent. That is the one which is called a Grignard reagent. So now let me start with my synthetic reaction. So I'm going to show that this is a synthetic reaction. So here, synthetic route, like that. So now how am I going to come up with the answer? I'm going to use a ketone to react with a Grignard reagent for me to have what I want. So I'm going to say, okay, so this is a synthetic route. So I'm going to say like this. So here I'm going to put this one to be a ketone. Have you seen? This is a ketone. Now when a ketone, here I'm going to say when a ketone react with a Grignard reagent, which is I'm going to, you know, a ketone when react with a Grignard reagent, it forms an alcohol, which is a tertiary alcohol in the presence of an acid. Don't forget about that. But here we're not showing a mechanism. I'm just going to write it. So here I'm going to use CH3 like this one, then magnesium, then here bromine like that. You see? So now here I'm going to have this thing. You know, when this alkyl come attach itself here on where there's a carbon containing compound here, when this one come to attach itself there, this bond, it will open. So here it will be something like this. So something like this. Okay, I'm going to show like the way it has been shown in the question. Like here it will be something like this, then here CH3, then here it will be something like this, which is O with a negative there, don't forget. So negative there, then here magnesium, bromine like that. You see? So this is a synthetic route. When reaching there, if I had a space, I can just use an arrow there just like this to go this other direction, but I don't have a space, so I'm going to use an arrow from here. Then I'm going to use an acid there in the presence of an acid. So here, you know, you can put in the presence of ether, like in the presence of disulfide, dimethyl ether, like that one. So you see. So now here, you know, this one, this acid, this negative here, which is a nucleophilic, it is the one that will come and grab this hydrogen which is here, and we are just going to remain with water there. So now here I'm going to write something like this. So now here to be something like this, CH3 like that one. Then here it will be something like this. See? Then here it will be O. Then since this oxygen has gotten the hydrogen there, it will be like this. Then this one at the end you're going to have water as well as magnesium bromine. But this is a synthetic route that I wanted. From a ketone reacting with the Grignard reagent, it will form something like this, because this one will come and attack there, then this one oxygen, the bonds, two double bonds will open, forming like that. Then after that, this will come and get a hydrogen, but I'm not showing because I don't need to use a reaction mechanism. I just going to use that, you see. So when I reach there, I'm going to say I've done with a synthetic route. You get? So now let me go to the analysis part. So here, here I'm going to write this analysis. So that's why I told you that we need to start with the synthetic part, because analysis, we are going in a reverse direction. We are going in the reverse direction. So look here, this is our answer. So I'm just going to go in the reverse direction, but I'm going to use a doubled arrow. How? So I'm going to get this one from where I ended. Okay, so let me just remove that. Then I just use this arrow. So here to be something like this. Then here it will be something like this, CH3. Then here, you see. So I'm going to use the doubled arrow like that one, you see. Then I'm going to go on this here. Remember what is that? This one. Okay, so here to be something like this, which is CH3 there. Then here it will be negative, which is an oxygen with a negative, then magnesium, then bromine like that. You see what we did. Then there will be an arrow again, this one. So here there will be an arrow like this. Then here it will be something like that, with a ketone like that. You see what we did from here. This one to that one to that one is a reverse direction. That is analysis part. So now, since it's analysis part, Now here we need to know if we were breaking a bond or we were forming a bond. So let me just take you back to this. So in the direction of when a ketone react with this, you see what was happening. This alkene here, or this alkyl, sorry, this alkyl, which is methyl, it has come to attach itself where this position to form this. So this is our direction, which is this, since that one is a reverse direction now. When this alkyl, it was coming to form this one, you know that a green reagent has to come with a alkyl group to come and attach itself where? There, you see, right? So now the bond which was formed, we didn't break, but we are forming a bond between a carbon and a carbon. We formed a bond between carbon and carbon. So here you are just supposed to write like this: C. The bond that you have formed is between carbon and carbon. You get, right? So now, so that one. So when you look at this, between here, sorry. Here is something like this. Here is something like this, because it was okay. So this is an OH like that. Don't forget, because here that's what we have formed here, which is an OH. So it was just going in the reverse direction like that. So in between this one from here, which is when our Q has come to attach here, then this one you find that this oxygen will grab the hydrogen here to come up with the this, which is an alcohol. Look here now, from here to here you find that you have there's a bond which has formed here in between oxygen and also what? Hydrogen there. So hydrogen and oxygen have formed a bond there. So that's the bond that you are going to have there, and that's the one that you are going to show. How? You're going to show it in this way, which is the O, then H like that. That is the one which is analysis part. Then you are done there. Just know the bond that you are forming or the bond that you are breaking there. Then question 2. Let me go on question 2. Here they are saying, how can we form this one using a synthetic route as well as the analysis. So I'm going to start with the analysis again. See, that one is an ether. Let me just write it here. Okay, it has got 4. Okay, fine. So here it is like this. Then here is like this, like that. This is an ether, you see? This is an ether. So which method can we use? We can use a Williamson synthesis of ether, whereby we use an alkyl halide together with the sodium hydride. How can I do that? So I'm going to get this from an alcohol. You know, an ether is coming from an alcohol reacting with a sodium hydride together with alkyl halide, then we come up with an ether. So now here, question this one, which is 2, like this one, I'm going to get this as a synthetic part, synthetic route like this. Okay, like this. So I'm going to use this as this one here, OH, you see, and OH, first of all I'm going to react it with the sodium hydride. When a sodium hydride, you know that the hydrogen will come and grab the hydrogen here, because hydrogen here is a negative, will come and grab the hydrogen there, then it will form this thing right here with a negative here like this. You get? So now, because this hydrogen has gone, you are going to form hydrogen gas. Then here it will have a negative because you have removed the hydrogen with the hydrogen there. So then what are you going to have there? See now. What are you going to have? Like this, you see? So okay, like this. So now here you are going to use something which is an alkyl halide. What alkyl halide are you going to use? So it's to look at this structure here, which is this part here. How many carbon are there? You can see here where I'm drawing with the lead pen. So here, how many carbon are there? It's only one carbon. It's the one that was attached to here, because we use an alkyl halide. What alkyl halide are we going to use? we're going to use ethyl iodine, because it's the one that is mostly used, iodine, as an halide. So if you look at the structure, if here there was a methyl or ethyl, we might we're supposed to use ethyl. If there was propyl, we're supposed to use propyl halide. But here we're going to use methyl halide, which is the CH3, then together with this with halide like that, which is the iodine. So you know that this one is the one that will come and attack using SN1 SN2 reaction on the primary of methyl there. Then this one will go, you're going to connect it here now with oxygen, you see. Then you connect, since this one will connect to that one, to the methyl here, to be like that. So you can show it like that. Like that. So it's the same thing. It's the same thing like that. You see? So now this is the synthetic part which we have just done. So let's try to look at now the analysis part. Let's try to look at the analysis part. So now what am I going to do? Let me just rub there in this part. Let's try to look at analysis part. Okay, I'm just going to write this. This is analysis part of the ether on question 2. So I'm going to go with this direction, but it will change. It will be in a reverse way. How? It will be something like this, you see, and here it will be negative like that. Then it will give me something like this. Sorry, this one it will be an ether, the one that will produce. Then the one which will be negative is this one, which is here, you see. Yeah, so after that, then to go to alcohol now, like this one. So here, so okay, so like that one, OH like that. Then I'm going also to look at so remember, on synthesis on analysis part, you are using a doubled arrows like here, like this. Yeah, so those are the doubled arrows that we're using. So now let's try to see if we are breaking a bond between what atom and what atom, or we are forming a bond. Looking at this here, this is a synthetic part here. Since that one now is a reversed one, let's try to look at the first here part, which is here. When you look at this one, between so this part, which is the first part here, is this part, is this part here. You get right? Sorry, it's this part here. You get? So the first part is this part, because now it's going in the reverse direction. So look here now. Here for us, we have removed the hydrogen to where there is an oxygen there. So what did we do? We have the bond which is here is broken, and what bond has been broken is the bond between oxygen and also hydrogen there, because you have removed the hydrogen and the bond which was there is broken. So what are we going to do? We are going to write here, O, then here H, like that one. You see, the bond here is broken between oxygen and the hydrogen there. Then when we come to this, which is between so when we come to this, which is the second part here, forming an ether, is this part now, you see. So what were you doing here? What bond were we making? So you find that this one here, oxygen, we were adding a methyl here. So what bond were we breaking the bond or forming a bond? We had to form a bond between oxygen and also carbon there. So the bond that I'm going to write is just oxygen and carbon like that. So that is a analysis part. Then you are done, and it was 14 marks. All right guys, so thank you so much for having this time with you.